Hey everybody, this is Larry. This is day 21st of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. I don't know, I'm just dancing with my hands today. I'm a little bit more rested today, but we'll see what today's problem. Oh, yesterday I guess I was a little bit of a mess, or maybe it was the day before. I don't even remember anymore. But yeah, today we have 2257 count unguarded cells in the grid. So you have a grid. You have guards at XY location, basically, okay? A guard can see every cell in the four cardinal directions unless obstructed by a wall. Another guard, a cell is guarded if there's at least one guard that can see it. Return the number of unoccupied cells that are not guarded. Okay, so what's the first analysis, right? Is that each guard, at the worst case, if you I mean, this is me, I haven't looked at the constraints yet, but given a grid of R times C, each guard, if you just go all the way up, right, it's going to be all of R, and all the way left and right, it's going to be all of C, so it's going to be R plus C times G, right? So that's if we do something really naive. But, yeah, and R times C is going to be 10 to the 5th. If we times that by G, it is going to be too slow. So then, okay. Can we do a little bit better, right? I mean, I guess we have to, but yeah. R times C is going to be 10 to the 5th, so you want something that's maybe constant, maybe adverse, adverse O of log n or something like this for some log n, maybe R and C. So one way that you can do it is probably just, or the way that first comes to my mind is just about separating the four directions, right? So we have four directions. We don't need to care about all of them. All we can have to do is just kind of keep track of all of them by state. And that's really all we need. And what I mean by that is that, okay, let's just say we only focus on one direction, which is going up. I don't know. Doesn't matter. They're all the same practically, right? You only need one direction. If you're going up, that means that each guard, I mean, and you can interpret it however way you want, really. But it means that each guard can only look up, right, in guarding. So that means that, okay, that means that you're going from the bottom all the way up until you see a guard. And when you see a guard, well, everything past that, as you keep on going up, then you cannot be in those cells, and then until you hit a wall, right? So those are kind of like, I mean, I know that went really fast, but I think if you take your time, you can definitely figure out the state diagram of, there are not many there are not that many states, right? You're given a cell, what was the last thing that you went past, or maybe nothing, and then that's it, right? So, and because you can do that in R times C, where R times C is the number of cells, which is, we know that's going to be bound by 10 to the 5th. And we don't care about the guards. We don't care about the walls, right? So that should be good. Yeah, and that's for one direction. Of course, if you need to do it in four directions, you can do it in four directions. And that's pretty much it, right? So yeah. So I think algorithmically, we got this. How would we want to implement it? I think, we can do it in a number of ways, but that's kind of, we know that R times C is going to be at most 10 to the 5th, so we can actually construct it out. There are other ways you can think about it. Some of it just depends on the nuance of the constraints, because if you want to say R times C, but then you also have G as a parameter, or maybe W as a wall, and maybe you want to optimize for G when G is really small. Let's say G only has two guards, right? Then, R times C is really big, then maybe, you optimize for it. For now, we're going to optimize for the worst case, which means R times C is going to be the worst case, so that's what I'll do. If it needs to be something more, differently, then, yeah, then maybe we'll do it differently. But yeah, we start with a board, I'm trying to think, what is the easiest way to kind of implement this? But I don't know, to be honest. But yeah, we'll just kind of write it as whatever, none maybe, right? And then yeah, and then we just for xy in guards, boards of xy is equal to, I don't know, whatever, maybe G, right? And then for xy in wars, board of xy is equal to W, something like that. I don't know. I mean, you could probably use a real enum. That's probably cheaper because a enum will only be a number of things. But I will at least write. Okay, let's at least we can write empty guard war is equal to 0, 1, 2. So we can do a fake enum, if you will. Let's do that. All right. And then now, what do we want to do? I mean, yeah, we can. The thing is that you have to start with some direction, so I don't know. Maybe for now, I mean, I think there probably is a clean way for you to just write it once and then kind of just like, the way that I'm thinking about, honestly, is that you can write it once and then rotate it 4 times and then kind of intersect all this stuff. But I think it's like easier said than done, honestly. Like, it's not that hard conceptually, but it's just easy to make mistakes. Maybe not even, honestly, but I'm lazy today, so I'm just gonna kind of brute force, or not brute force, but just like write it out, unroll the loops, if you will, right? So then now we go, okay, do the up direction, right? So okay, so oh yeah, so maybe here we also want to write maybe empty, maybe not, maybe we'll just call it free and guarded, right? So yeah, maybe that's slightly better, right? Something like that, right? And now we want to do the up direction, then we have to go from bottom up, right? So then now we just do for x in range of something, right? We don't know yet. I guess it doesn't. And then for y in range of something. And here, y doesn't matter because going from left to right, you could think of it almost, you could do them even in parallel, really. So it doesn't really matter. So here you can go from y from, you know, to c. Here we probably want to bottom up, so we do -1, -1, -1. And for me, bottom is going to be higher on the x scale. I mean, you could write it however way. I mean, because you have to do all 4 direction, right? So the direction for this particular problem doesn't matter as much. Anyway, so then here maybe you could see like last is equal to 3, right? Maybe something like that. And then here, if board of xy is equal to guard, then maybe last is equal to guard. Then we have to change it anyway. Else, if board is equal to war, then last is equal to war. Otherwise, then now, well, we'll just do if it is equal to 3, right? Because if it's equal to, if it's already guarded, it doesn't actually change any state, because you cannot go from guarded to unguarded, right? Once it's guarded, it's guarded. But once it's free, then now we take a look. If last is, and maybe you could say this could be a switch statement. I don't know. It's fine. Three things is probably like around my personal limit for if versus switch. I don't know. But yeah, if last is equal to war, then, or actually if last is equal to guard, then board of xy is equal to guarded. Otherwise, then actually, you know, if the last thing is either war or free, or, well, just war. Also, I kind of messed this up. I messed this up a little bit. Yeah, because you were going on the x, right? So, and we're keeping track of last, which is the state. So we actually want y to be in, on outer loop, so that we can initiate last for every column, and then for each column we do this, right? Anyway. If last is equal to guard, then we put guard in. Otherwise, it should stay free, I guess. But because it's already free, we should not need to write it out, right? Because the other states are, it was either, well, a war. If it's a war, then it just remains whatever it used to be, right? So yeah, and keeping in mind that once it turns to guarded, you know, nothing can change it back, and this is only if it's free. So this should be good, right? I think so. The tricky thing is that I know this is going to be reused, so that's a little bit sketchy. Maybe we could have been a little bit smaller or something here on the reuse, but for now, you know, we'll just worry about getting it correct first, and then we'll see. And then we'll do the down direction, which is going to be exactly the same, right? So we'll even copy and paste. except for now we're going down, so this is going to go from 0 to R, and everything else is the same. So pretty straightforward, really easy copy and paste, which probably gives you a hint that you can also maybe easily refactor this. But again, maybe I'll do that next time or something. Anyway, for going to Y, the rows don't matter. Last is equal to 3. For Y, we will go from left to right, right? So right. And then and then again, actually, this part could be copied and paste, which is why I was saying like, maybe we could have done some, I don't know, and then do the right direction remaining thing, right? So yeah, and here again should be the same, except for the inner loop is going to go from left to right, right? And that's really it. And then now we just count up all the free cells, yeah, and we should be good. Did I mistype something? Why did it? Okay, I don't know. Maybe computers are hard. No one knows why things happen. Something like this, right? And you should be good. Let's give a quick submit. And yeah, we look Gucci. I mean, this is going to be 4 times R times C. Like I said, if G is like really small, you could probably do some math on trade-offs. If G is like really smaller than R and C, you could probably do some optimization around that and doing maths and intersect things. I mean, at worst, you know, you can do some like if G is really small, you can use what's it called? Inclusion exclusion principle, for example, to kind of, you know. That, and there are probably other things like sweep line, for example, and other things. Excuse me. So yeah, there are other things you can do, but I don't know. Like you can do what's it called, coordinate compression as well if G is really small. But I'm not gonna do any of that because I don't know, that requires more work, and I just want to sleep. Apparently, I did it basically. Oh wow, I basically did it the same thing last time. That's kind of cool, I guess. I don't know. Anyway, that is all I have for this one. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy, to your mental health. I will see y'all later and take care. Bye bye. Oh, look, it's turkey. Thanksgiving was almost here. So hope you enjoy it. Anyway, bye.